Okay, so today we're going to be learning about how accident investigation data is used in car accidents. You should have hopefully looked up all of the definitions for the key terms already. I want to go over the review, the warm-up, okay? So to solve for x here, all I would do is go ahead and multiply 2 times 32 inside the square root. So that would give me x is equal to the square root of 64. I want to think what same number times same number makes 64. I could also do this on my calculator, but I get that x would be equal to 8 because 8 times 8 is 64. So this would be your answer there, okay? The second one, when I'm solving for x and it's inside the root, what I want to do is I want to undo the root, so I can undo it by squaring because that's the inverse operation, but then I have to square both sides of the equation. So I'm going to get 36 equals the root and the squared will basically undo each other or cancel each other out, so I'm left with just whatever's inside. And now I can go ahead and solve for x by dividing. So I get for this one x is equal to, I believe that's 18, okay? So there's the answer there. Okay, in addition to all your definitions you wrote down, I want to give you guys a few things that I want you to make sure for sure that you got. So one of the things is under skid speed formula. I want to make sure that you guys have that correctly and that you've noted everything. So if you don't have room to write here, you can maybe write up here if you need some more room. But let's go ahead and make sure that everyone has the skid speed formula is S is equal to the square root of 30 times D times F times N. And I want to go over what all of these things are, okay? So the S would be our speed. Okay, the D would be the skid length. F is going to be your drag factor. Okay, we want to make sure that we don't get these two mixed up because the D does not stand for drag factor. It stands for skid length, okay? And then N is your braking efficiency. Okay. All right. There is another formula that we sometimes use for our speed, okay, for how fast the car was going, okay, when it entered the skid, and that formula is different when we're not looking at skid length, but when we're looking at yaw, which is when it makes a curved mark instead of a straight mark, okay, and so that formula is going to be slightly different. So it's going to be S is equal to the square root of 15 times F times R. And in this case, F is still going to be your drag factor. Okay, but in this one, R is going to be equal to the radius of the circle created by the yaw mark. Okay, and it might be helpful for you guys also to write down the formula for how we find the radius. So I'm going to go ahead and I'm going to write that down up above because I don't think we have room here. Okay, so I'm going to go up to the top and I actually want to draw for you guys what all the different parts of the yaw mark are so that you understand what's happening. So sometimes the car will kind of spin as it's skidding, and so it creates this circular yaw mark. That's what it's called. Okay, the distance from here to here, okay, this is called the chord. So this is your chord length. We usually use the variable c to represent this, okay? Then we have this distance here, which if I drew this at a complete right angle, a 90-degree angle, this distance here is the middle ordinate, which usually that's represented by the variable m. Okay, now, if we were to actually like take this circle and continue it all the way into a full circle, I would, if I were to draw in like a radius, the radius is from like the center of the circle to the outside edge, okay? That would not necessarily be the same as the chord, so that imaginary line that I could draw in, that's your radius, which is r, okay? Now, it's important that we are able to find r so that we can plug it into our speed formula that we wrote down down below. So how do you find r if r is not given to you? Well, there's a formula for r. So to find the radius, your formula you're going to use is r equals c squared, which is your chord length squared, divided by 8 times m. M is the length of your middle ordinate. And then we are going to add to that m divided by 2, okay? So most of the time they have all these two measurements, and that helps them find the radius. And then with the radius, what we can do is we can plug in the number we get for the radius into our formula for our speed, okay? All right, we are gonna go ahead and do some examples, okay? So let's go ahead and take a look at example 1, okay? So for example 1, okay, it says a car is traveling on an asphalt road with a drag factor of 0.78. So they've given us our drag factor here. The speed limit on this portion of the road is 35 miles per hour. So this is our speed limit. This does not mean that that is the speed we were actually going when we got in the accident, okay? The driver just had his car in the shop and his mechanic informed him that his brakes were operating at 100% efficiency. So this is representing your braking efficiency, okay? The driver must make an emergency stop when he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. So this is your variable that's going to be D for your skid length. This variable up here is going to be F for your drag factor. And then this variable down here, your efficiency, this is going to be N. Okay, we always want to write that percentage as a decimal. So if I took my pencil and I moved the decimal point 2 places, I would get that N equals 1.0. So I'm using 1.0 for my N value. Okay, now remember, I'm plugging it into the formula that we wrote down, which was S equals the square root of 30 times D times F times N. So let's just go ahead and plug everything in to find our speed, okay? So when we plug in, we're gonna get our speed equals the square root, okay, of D was our skid length. Our skid length is 80, so 30 times 80 times our F value. Our F value was our drag factor. Our drag factor was 0.78. And then times our N value, which was our braking efficiency, that was 1.0. Oops, 1.0, okay? So we're gonna go ahead and multiply all these things and then take the square root, okay? So when we do that, I believe inside we get the square root of 1,872, and it said round your answer to the nearest tenth, so that means one number after the decimal place, so we're going to go ahead and round that to 43.3, and this is our speed, so we're talking about miles per hour. So this would be your answer here. Okay, now the second question says, was the driver exceeding the speed limit when entering the skid? Well, what was the speed limit? It told us up here the speed limit was 35 miles per hour. So was he exceeding it? Yes, he was exceeding the speed limit. Okay. All right. if you are done with that, let's go ahead and flip over to the back of our sheet. Okay, so question number two. Question number two says Melissa was traveling at 50 miles per hour. So it's actually giving us her speed. This is our actual speed, which is 50 miles per hour. Okay, on a concrete road with a drag factor of 1.2. So 1.2 is going to be our value for F, which is our drag factor. Her brakes were working at 90% efficiency. So this is going to be our N value, but we're going to use moving the decimal 2 places. So N equals 0.90. Okay. So it says to the nearest tenth of a foot, what would you expect the average length of the skid marks to be? So it's asking us for the length of the skid marks. Remember, the length of the skid marks, this is our D value in our equation, so we're trying to find that, okay? What would the average length of the skid marks be if she applied her brakes in order to come to an immediate stop? All right, so let's go ahead and plug in to the formula. So I'm going to plug into that formula again. S is 50 equals the square root of 30 times D. I don't know what D is, so I'm going to just leave it a variable. Okay, times F. So that would be times 1.2 times N, which is our braking efficiency, which is 0.90. Okay, I'm going to go ahead and multiply everything inside here that's actually numbers. So I'm getting the square root of 32.4, and I still have my variable D. Now remember, just like in the warm-up, when we have the variable inside the root to solve, we want to take both sides of the equation and square them, because that will undo the root. So let's square both sides, okay? And so now I'm going to go ahead and get 50 squared is, I believe it is 2,500, equals, and then when I square and square root, that just undoes each other, so I just have what's left over inside. Okay, and last I'm going to divide both sides by 32.4. So here's what I get for my distance, and it told me, did it tell me about rounding? I don't know if it necessarily told me, but I'm just going to round to the tenths place. So my distance here is equal to 77.2, and that distance is in feet, okay? So there's my answer there. All right, let's go ahead and let's move on to the next question, number 3. Okay, it says an accident reconstructionist took measurements from yaw marks left at a scene using a 43-foot length cord. So we know the cord length. She determined that the middle ordinate measured approximately 4 feet. So I know the middle ordinate is 4 feet. The drag factor was 0.8. Okay, it says determine the radius of the curved yaw mark to the nearest tenth of a foot. Okay, so we're going to use that formula we wrote down on the front for radius, which is the chord length squared over 8 times the middle ordinate plus the middle ordinate divided by 2. So I'm just plugging everything in there. So the radius is going to be my chord length squared, so 43 squared, divided by 8 times my middle ordinate was 4 feet, plus the middle ordinate, so that's 4, divided by 2. All right, so I'm going to go ahead and square that, which is giving me 1,849 on the top, divided by 8 times 4 is 32. And then 4 divided by 2 is 2. Okay, so now I'll go ahead and do this division, all right, and add 2 to it. And then I'm going to round to the tenths place. So when I do that, I get about 59.8 feet, okay? Now, I've rounded this already, okay, to the tenths place because that's what the instructions told me to do. Okay, So next it says determine the minimum speed that the car was going when the skid occurred. Okay, so remember that formula we wrote down from the front. When we have yaw, we're using a different speed formula. So that speed formula is S equals the square root of 15 times F times R. Okay, and remember, F is your drag factor, R is your radius. So now that we have the radius, we already were given the drag factor up here. Our drag factor was 0.8 in the original problem. So now I can plug everything in to determine the speed. That's what this question is asking me to do. So I'm going to go ahead and say S equals the square root of 15 times my drag factor is 0.8 times R, my radius is 59.8. Okay, now that I've gone ahead and put all those things in, I'm going to just evaluate. So inside the root, I end up with 717.6, and then I'll go ahead and round it to the tenths place again because that's what the instructions say. So after I take that root and do my rounding, it's about 26.8, and this is our speed, so it's going to be in miles per hour. Okay, so you have here your radius, and then here you have your speed. Okay. All right, let's go ahead to the last one. All right, so the last one says determine the minimum speed of a car at the point the brakes are immediately applied to avoid a collision based upon a yaw mark chord measuring 62.4. So this is the chord is 62.4, and the middle ordinate measuring 5 feet. The drag factor of the road surface, so here's your drag factor, is 1.2. Round your answer to the nearest tenth. So we're basically going to do what we did before in the two parts with this information to find our answer for the minimum speed, because we can't find the speed without first finding the radius. So we need to do this, and then we'll move on to do this, okay? So to find the radius for this situation, we're going to do C squared. So C is 62.4 squared divided by 8 times the middle ordinate is 5 plus 5 divided by 2. Okay, we're going to go ahead and... All right. Okay, so I'm just going to continue simplifying this expression that I have here. So I'll get 3,893.76 divided by 40 plus 2.5. And I'm going to just continue do that division and add 2.5. I'm going to round. It said round my answer to the tenths place. So I'll get 99.8. Okay, this is going to be in feet because this is my radius. Now that I have my radius, I can go ahead and plug into my speed formula. So I'm going to get 15 times F, which is my drag factor, so that's 1.2, times 99.8. And I'm going to go ahead and multiply and see what I get there. So 15 times 1.2 times 99.8 is giving me 1,796.4, and then I'm going to go ahead and take the root of that and round to the tenths place. So when I do that, I get about 42.4. Now this is a speed, so this is going to be in miles per hour for my answer. So this would be your final answer for this problem.